Hello, my name is R. Mohan Purnachandra, and today I'll be presenting my data engineering final project, which is a real-time data streaming platform which I've built. And the track I've chosen is a crypto market tracker using CoinGecko API. And first, I've built the ingest.py file to ingest data from the CoinGecko API. I'll show step by step on how I have built the Python script, the SQL queries to create the tables, and how I have deployed it in Snowflake. So let me just start by showing the ingest.py file. In this file, I've used the CoinGecko API with this module, and these are the cryptocurrencies I want from this API, and these are the country currencies in which I want the crypto prices. So this is the line which gets data from the API. I don't need to use any API key. It is done without any API key. I've also handled the 429 error, which is the rate limit error. And if there is any other kind of error that happens, the code will still not break. It will give us the output, the error output, but and still run. So once I get the data from the API, I'll store it in the path and I'll convert it into the JSON and store it there. This is the landing zone. So I'll run this script. So this is the landing zone. And whenever I run the script, it checks if this landing zone folder is there or not. And if it is there, then it will dump the content of the data. So if we can see that there are the only three JSON files. And if I run this, another got created. The naming of this is random so that we can get more and more API, more and more files. So this is how the output of the API is. We have the current cryptocurrency name, the prices in various currencies, and the last updated at. This is measured in seconds and can be converted into a particular date. So this is the entire setup of ingesting data, and now I have created it tables. I've created it in Snowflake, so I'll first go to Snowflake. Yeah, this is Snowflake, and I have created a database for this project called Cryptopedia. I've added three schemas: data ingestion, data processing, and data storage. So in the ingestion, I've added a stage called CoinGecko data that will get the JSON script which we have generated earlier, and it is then loaded into the raw CoinGecko table. And this is done, all of this is done using the worksheet in this worksheet. Yeah, I have it here. Yeah, in this worksheet, first I use the schema and I create the raw CoinGecko table. First I create a table in which it is completely raw, like the JSON is converted into a table. That's it. And then I refine that into a CoinGecko metrics table, which is a rough, which is our first normal form. I'll show the table as well. Yeah, the metrics. So this is the table. All of the values is boiled down into single entity, and we have around 36 rows in this. I ingested a few data in this already. And after that we create, now we'll convert this into a star schema. I'll explain the star schema, the ER diagram. So this is our star schema. The fact table contains three columns: coin ID, current ID, and time ID. And it links with three other dimension tables: the coin ID and the coin name. I'll show the values of these. Yeah. So this is the coin ID and the coin name: Bitcoin, Picoin, Ethereum, etc. And we also have the currency. This has 5 columns: currency ID, name, value, volume, and market cap. And in the time dimension table, we have 2 columns: time ID and the last updated time at time. And the fact table merges all of these into a single, and this is the star schema we get, and this fact table is here. We have stored it in the data storage schema, and all of these are loaded. So this is our coin ID, currency ID, and time ID relationships. So from this we can access we can bring this raw table whenever we want, this table whenever we want. And this is the entire script which does it. I create these dimension coins, currency, time, and fact table, and then I insert the values from the CoinGecko matrix table, and I've also checked whether the count is there any null value in the 3 columns of the fact table. And then what I've done is created a Snowflake stream in order to, yeah, I've created Snowflake stream so that I can run this automatically and with Snowflake tasks. So in this, the name of this stream is raw CoinGecko stream. This is working on the table raw CoinGecko, which, and now I create a task called CoinGecko pipeline tasks. And what it does is I show the code of it. Yeah, it has the warehouse, compute warehouse, and it works on the stream raw CoinGecko. So whenever data is ingested into the raw CoinGecko table, the stream gets activated, and from the stream, the task is activated. So I insert all of this into the CoinGecko matrix table, and then later from that table, it is boiled down into these smaller dimension tables and the fact table. So we get the entire structure which we just saw earlier. So this is the entire project, and this is the entire code. And thank you.